Hello, today we are presenting about electricity. We are students from Konkan Vittayan School, which is in Konkan City, Konkan Province, which is located in the southwestern part of Thailand. My name is Pun.
My name is Mankorn.
My name is Poom.
And my name is Ton Peep.
Yeah, let's watch the video today for all of the avid bomb makers.
Oh no, that's a bomb. What shall I do? I'm gonna call Pun. Pun, how do I defuse a bomb?
You gotta cut the black wire, Todd.
Okay.
Wait, Tommy, that's the red wire. What are you doing?
No. How does the bomb even work?
That's fine.
To understand how a bomb works, we first need to know what electricity is. Electricity is using electrons to do work. A material's conductivity affects how well electrons move. According to Ohm's law, which states voltage equals current times resistance. Voltage is simply just the electric potential difference between 2 points, positive and negative, measured in volts. Current is how many electrons are flowing, which is measured in amperes. Resistance is how well a material resists the flow of electrons, measured in ohms.
Now let's look at some basic components. These are resistors. They provide resistance. It's measured in ohms. They use this symbol and look like this. Capacitors can store and release electricity quickly. They are measured in farads. And these are some capacitor forms. Polarized capacitor only works in one way, and non-polarized capacitor works in both ways. And these are its symbols. Diodes only let current flow in one way. Another type of diode is the center diode. They only conduct electricity when the voltage is high enough. This is the symbol for both a normal diode and a center diode. Transistor either amplify or switch the current. They are controlled by the current on the base pin, which is this pin. NPN transistor switch with a positive voltage, while PNP switch with a negative voltage.
In this part, we will show some real-life examples of circuits. This is a current limiting circuit. This is a current limiting resistor using the formula where the resistance is equal to the difference in supply and required voltage divided by your desired amperage. In this case, we use a 100 ohm resistor to limit the current to 20 milliamps. This is a showcase of a series circuit. When a circuit is in series, it has one path for the entire circuit to flow. Now, when the LED is taken out, it breaks the circuit path. Now, this is a parallel circuit. We will also disconnect one of the bulbs. When a circuit is in parallel, there are multiple paths for the circuit to flow. This time, each bulb completes the circuit's path independently, so it keeps the circuit closed. This is a showcase of a voltage divider circuit. The voltage division formula is represented by the following formula. The output voltage equals the resistor to ground divided by the total resistance times the input voltage. Now, we use two equal resistors in this circuit to have the voltage. As you can see, the LED is much dimmer. The circuit has no capacitor. When there's no power, the LED turns off. But when I add a capacitor in between the LED, let's see what happens. As you can see, the capacitor charges up and discharges, causing the LED to turn dimmer instead of fading off instantly.
These examples show the basics of electricity and simple circuits. Every electronic device, from a flashlight to a computer, follows the exact same principles. This is simply just the surface of how electronic power the world we live in today.